quadratic inequalities. There's not a lot of room in your notes for this to be added, so you'll notice I just kind of stuck it down here at the bottom left of page 65 in your guided notes. We're going to talk about solving quadratic inequalities. I'm going to move over to this blank page so that I have room, but essentially that's where we put it when we did it in class. So solving quadratic inequalities are identifying which values of x make the inequality true. Specifically, let's recall how we solved a linear inequality. Linear inequalities are pretty simple. Essentially, when you're taught to solve a linear inequality, you're just getting the x value by itself. So all the rules for solving a linear equation applied, except we decided that when we divided by a negative number, then we had to switch the inequality sign. In this case, if I'm trying to isolate the variable x, I would subtract 1 over to the other side, and I would end up with 8 on the right hand side, so 2x has to be less than 8. I would divide by a positive 2, so the sign will not switch, and we would conclude that x is less than 4. So what does that mean? Well, it means that if we choose any value that is less than 4 to plug in for x, it will make the inequality true. For example, if I choose the value 3 is less than 4, and I put 3 in for x, the value should create a true inequality. So if this is 6 plus 1 is less than 9, right? 7 is less than 9, that is true. If I were to choose any value less than 4, I could choose negative 10, right? And negative 10 and plug that in here. That should also give me that same result. So I go negative 20 plus 1, negative 19 is less than 9, which is also true. So any value less than 4 should work in this inequality. Notice it doesn't include 4, so we won't actually include the value 4, because if you put 4 in there, it will equal 9. And remember on the number line, if we were drawing this on the number line, we would draw, a lot of times your teacher had you put 0 there, but essentially 4 would be over here, and at 4 we would do an open circle because it didn't include the value of 4, and then we drew an arrow in the direction that represented all the solution values, so x is less than 4. With a quadratics, they create parabolas, remember. So sometimes they will have sections of solutions that may be two distinct parts of the number line. So with a quadratic inequality, essentially your steps are going to be similar. You're going to treat the equation first or treat the inequality like an equation. So you're going to essentially write the inequality relationship as an equation, and then solve the equation. So again, we can use all of the solving techniques that we've learned if it is in fact an equation. That zero product property is only going to work if it's equal to 0. So that's what you're going to do first. Once you do that, we are going to use the solution values to create kind of a number line where we're going to test some points, okay? So use the solution values as critical points on your truth table, or I'm going to write number line. We're going to draw a little number line, and then you're going to test points to identify solutions. Okay, so if we look at this first one, we've got x squared plus 4x minus 32. So step number 1, I'm going to write it as an equation. I'm going to have x squared plus 4x minus 32 equals 0. If that's true, then I can use all those solving techniques we've practiced. This one is already equal to 0. There's no greatest common factor. I'm going to look to see if it's factorable. We think about things that multiply to negative 32 and have a difference of 4. That would be like 8 and 4. So we would want x plus 8, x minus 4. Notice if I'm solving, then I can identify those solutions rather quickly. X is equal to negative 8. X is equal to positive 4. Again, those are not the solutions necessarily to the inequality. And actually, if you look at this inequality, it's greater than, and it doesn't even actually include those two solutions. So if I'm thinking about the number line, and here's 0, here's positive 4 over here, it doesn't actually include that value. And here's negative 8 over here. Again, it doesn't actually include that value. So the difference between in the linear inequality is it's just one side or the other of the value. But here, our solutions could exist between here, or they could exist in this section, or they could exist in this section. So we call these critical values, and we just choose a value within the specific section to test if it's true. So for example, if I wanted to see if values greater than 4 were true for this inequality, I could choose the value, say 5 or 6 or 10. And then I just plug that in. So let's say I come up here, I take my inequality, and I'm going to plug in the value 5. So when x is 5, then I would have 5 squared plus 4 times 5 minus 32, and we want to see if that really is greater than 0. So that would give me 25 plus 20 minus 32 is greater than 0. So 45 minus 32 gives me 13 is greater than 0. That's true. 13 is greater than 0. So we would say this section over here, those values are true. Notice if I choose a value between negative 8 and 4, so let's say I just choose the value 0, just because that's right there between it. And if I look at when x is 0 and I plug it into that inequality, I would get 0 squared plus 4 times 0 minus 32 is greater than 0. So 0 squared is 0. 4 times 0 is 0, so negative 32 is greater than 0. That's a false statement, so that means that between here, those do not work as solution values. And then we could do one more on the left side. So if I choose any value over here that's less than 8, so let's say I do negative 10, I would get negative 10 squared plus 4 times negative 10 minus 32 is greater than 0. And if I simplify this, negative 10 squared is 100. 4 times negative 10 is negative 40. Minus 32 is greater than 0. And if we're looking at that, right, that would be 100 minus 40 minus 32 would give me 28. And 28 is definitely greater than 0. So that is true. So you'll notice it's here true on both ends. Now, one thing about a parabola, because they are parabolic in nature, they create that U shape. So you'll find that it's going to be true on kind of both ends if it's false in the middle, or if it's false on both ends, it'll be true in the middle. And if you think about, you don't really need to draw this parabola, but if you think about the parabola, if I were to draw it, this guy's opening up, there's no negative out front. So it's kind of a parabola that would look something like this. And it's a greater than symbol, so notice these two ends are where the parabola would be greater than that x-axis. So when I write this solution, I would say x is either less than negative 8 or x is greater than 4, and those are our two solutions there. I'll do one more really quick just to kind of show you another example, but essentially those are the steps and you just follow them over and over. If I'm looking at this one again, following those same steps, I'm going to write it as an equation first. 2x squared plus 3x minus 2 is less than or equal to 0. If I look to factor this one, oops, I say write it as an equation, and then I wrote it as an inequality. Equals 0. Again, I'm going to try and factor this one because it's already now equal to 0. And I'm going to write this as 2x and x. And then I just need to find factors of 2, so 1 and 2, that will work with my 2x times x in the beginning. And we want to end up with 3x. So it looks like if we do 2x times 2, we'll get 4x. And then we subtract the 1x, will be good. So I'm going to put the 2 over here, the 1 here. And I want to have a positive 4x minus 1. So again, you can check to your work if you need to. That would be 4x. This would be a negative 1x. That would give me that 3x. Okay, so my solutions then, I can pull from here. This would be x is equal to a positive 1/2 or x is equal to -2. So here's my number line. Those are my, again, critical values. If this is 0, -2 would be about here. And if you look up here at this symbol, this is a greater than or equal to. So I'm going to fill in the circle to remind me that it does include the value -2. And then I would have the value 1/2 over here. It's also going to include that value. Then we choose some values within the sections to test. So if I want to choose a value over here, maybe I choose the value +1. If I plug in +1 to my inequality, so when x is 1, I would have 2 times 1 squared plus 3 times 1, and I need that to be less than or equal to 2 to make it true. So again, I'm going to simplify. 2 times 1 squared is just 2, plus 3 times 1 is 3. So we get 5 is less than or equal to 2. It appears that that would be false. So this section over here looks like it's going to be false. Again, if I choose a value between the critical values on my number line, again, I could choose that value 0. So when x is 0, I could have 2 times 0 squared. It just makes my life easy. Plus 3 times 0 needs to be less than or equal to 2. So this becomes 0, 0. So 0 is less than or equal to 2, which is absolutely true. And then I'm going to choose one more on this side. Again, I think it's going to be false because of the nature of a parabola. But let's just test it just to see. So I'm going to choose -3. And when x is equal to -3, we would go 2 times -3 squared plus 3 times -3 is less than or equal to 2. So as I simplify, -3 squared is 9, times 2 is 18. 3 times -3 is a -9. And if I subtract 9 from 18, I get 9 is less than or equal to 2, which is false. So if I'm writing this solution, the solutions only exist between my two critical values. So I would say -2, and it includes -2. And I would go all the way up to 1/2. So this one would be inclusive. All right, that's solving a quadratic inequality.